Class, what's up? Welcome to our next video. We are continuing doing more things with triangles. I guess I kind of lied. There's more. So today we're jumping into some angle relationships. We've kind of focused more on sides recently, so we're jumping into angles. Some of this stuff you guys might already know, but it is good to review, and we're going to do some problems on it. So pay attention. Here we go. Triangle sum theorem. This is just saying that the sum of the angle measures of a triangle is always 180 degrees. No matter what has to happen, can't change, will never change. If it did, I don't know. I think the world might end. All right. Measure of angle A plus B plus C, it has to equal 180 degrees. All right. Next topic, we call this the right triangle corollary. Really what this is doing is it's just taking the triangle sum theorem a step further. And we're going to say that in a right triangle we always have a right angle and then two acute angles. What we say is the acute angles in a right triangle are complementary. And if we remember that word, what chapter? Chapter 3, I believe. Excuse me, sorry. They have to equal 90 degrees. All right? So that means that when we take our acute angle A and we take our acute angle B and we add them together, we find the sum, they have to equal 90 degrees. All right? So that's pretty easy. And even further, and I guess we did this yesterday a little bit, equiangular triangle corollary is basically just saying that the measure of each angle in an equiangular triangle is 60 degrees. Why is that? That's because 180 divided by 3 equals 60. All right? And we remember equiangular means equal angle, so they all have to be the same. So that means 180 divided by 3 gets us to 60, so 60 degrees. All right? Now, for some things that might be a little bit newer, I'm going to draw some triangle. Maybe, there we go. I got my triangle. I don't think, well, I hope you guys understand something like interior, exterior. And really, all we mean here is all the points inside the figure. Exterior, all the points outside the figure. And again, points, you can put points all over this. We don't need to. I'm just going to say this is interior. So anywhere inside, and then of course anywhere outside is exterior. Now what we do need to talk about is interior angles and exterior angles. Interior angles are formed by two sides of a triangle. So I have 1, 2, 3 interior angles. Interior angles. 1, 2, and 3. Alright, they're inside because I took one side, I took another side, and angle 1 was formed by those two sides, or angle 2 was formed by these two sides, or angle 3 was formed by these two sides. Alright, so that's how that works. Exterior angles are a little bit different. Exterior angles are formed by one side of the triangle and the extension of another side. So for example, if I extend this a little bit, what did I just do? I created an exterior angle. I could also extend over here, right? This is an exterior angle. I could even extend over here, exterior angle. Okay, so all you're doing is extending a side to create an exterior angle. We'll need that in a little bit, so hopefully you understand that conceptually. And as we flip, we talk a little bit more about what a remote interior angle is. Alright, so let's come up a little bit. Please fold. Alright. So each exterior angle has two remote interior angles, and I think this would be best to draw a picture for. So I'm going to sketch a picture. Alright, and I'm going to say that this is the exterior angle that I'm talking about. Okay, this is my exterior angle that I care about right now. A remote interior angle is an interior angle that is not adjacent to the exterior angle. So think with me here. If this is my exterior angle that I'm working on, and I have three interior angles, which one is not a remote interior? This one right here is not a remote interior because it is adjacent. We just said it cannot be adjacent. So what I would say here, remote interior angles, and I would point. Alright? So again, wherever that exterior angle is, and it can be drawn anywhere, you have to decide what are the two remote interior angles. And what you do is you look for the two that are not touching. Alright? Okay. The reason we do this and need to understand is because the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interiors. One more time, the measure of an exterior angle is equal to the sum of the measures of its remote interiors. So by that, if we look at angle 4 right here, what are the two remote interiors? Well, it's not 3. 3 is touching. So that means it has to be 1 and 2. So the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Alright, it's going to equal the sum. Oh my gosh, so many little notes. So many little notes. I want to do some practice problems. Alright, last note. If two angles of one triangle are congruent to two angles of another triangle, then the remaining pair of angles must be congruent. The easiest thing for me, I always like to write this. This is called no choice. No choice. What I'm trying to get at here, and remember, triangles always have to add up to 180, right? So if I know that A and D are the same measure, and B and E are the same measure, well then it just makes sense that C and F have to be the exact same measure. So again, if two angles of one triangle are congruent to two angles of another, so like A and B are congruent to D and E, well then the remaining pair has to be congruent. So CF, and we can write that in to finish up our notes. Angle C must be congruent to angle F. Alright, holy cow. So now that we've done all of the notes for this, let's do a few practice problems. I'll try to cut this off around, well, let's see how far we get. Let's see what we do in a good timely manner. So let's flip. A couple of these are going to be super simple, and I think you guys are going to do great at them. So let's start number 1. This is just your standard triangle. You have two angles. You want the third. This is one where I would want to see measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. And then start plugging stuff in. 43 plus 85 plus measure of angle C equals 180. What do we have there? Is that 128? So the measure of angle C must be 52. That sounds good. I like it. Alright, of course, use your calculator if you need it. feel free. I probably should be using it to make sure. So that was a really easy problem. There will be some of those, but don't get used to those. All right. This next one, number 2, is a little tougher. We have a right triangle, so I'm going to draw a right triangle. So I have a nice sketch or a picture. Now here's the goofy part. It tells me that the acute angles are in a ratio of 3 to 2. What that means is, well, this might be 3, this might be 2. Or this could be 6 and 4. Or 9 and 6. Right? It has to just always go in that increment of 3 to 2, 3 to 2, 3 to 2. So what I want you guys to understand is that means there is some multiplier that is going to be multiplied by both 3 and 2 that makes this problem work. And when there's a multiplier, I want you to think x, or some variable. So I'm going to write this as 3x and 2x. Because again, I don't know if x is 1 or 2 or 3 or 50 or 1 million. Well, it's probably not 1 million. But you know what I'm saying. All right, I know that somehow they're going to have to be in the ratio of 3 to 2, so I have to use what I know now about right triangles to figure this problem out. Now, if you remember, acute angles of a right triangle are complementary. So I know that 3x plus 2x should equal 90. Or I know 5x should equal 90. Or I know that x should equal 18. And now that I have that, I can answer the question, what are the measures of the acute angles? Well, 3 times 18 is, what is that, 54? And 2 times 18 is 36. So those are my 2 angle measures. All right. Ooh, I really like question 3 because this incorporates an idea from the other day. What did we say, what did we learn in our everything you ever wanted to know about triangles section? We knew that because of these congruency marks, meaning isosceles triangle, do you remember this? If sides, then angles? I hope you remember that, because I can make some tick marks, and I can say that these 2 angles are going to be the same, which means that when I go and I write measure of angle A plus measure of angle B plus measure of angle C equals 180, and I start to plug in, well, yeah, A is 38, B is X. What can I write for C? I hope you said X, right? If B is X, then C has to be X. And so now I have something that I can definitely solve. 38 plus 2x equals 180. Oh, my pen, come on. Equals 180. If I subtract 38, what does that leave me with? 42? 142? And then lastly, I would divide by 2. So x equals 71. Boom. Got it. All right. We're getting there, guys. I know it's going a little longer than I wanted it to, but I think these are all really good problems. I want you to see at least one example of all of these so that you can really try some of these on your own tomorrow. Or the next time I see you, I should say. All right. Take a look at this picture. See what it's giving you. See what it's giving you. If I see this picture, I'm seeing exterior angles, I'm seeing remote interiors. This is a situation where I would want to use that theorem now, that the exterior angle, or an exterior angle, is equal to the sum of its remote interiors. Excuse me. So, I know that 126, which is the exterior, has to equal the interior plus the other interior. Alright, exterior equals remote interior plus remote interior. So I start to clean this up. What do you have? 11x is at plus 16. Oh, this works out nicely. When I move this over, I'm down to 110 equals 11x. And of course, then x equals 10. Now be very careful. Did I ask for x? No. I asked for the measure of angle J. So measure of angle J should equal 5 times 10 plus 17, or 50 plus 17, which is 67 degrees. All right. Let's do these last two. I think you can stick them out with me. I sure hope so, at least. I got to draw a picture here. All right. So Hij. So let's do something like this. Try it. Okay. So if we call this H and I and J, it says I is 47 degrees. It tells me that the measure of an exterior at H is 120. So maybe I'll do like this, and I'll put that. Okay. Ooh, and I want the measure of angle J. So maybe I'll put an X there, because that's what I'm looking for. This is the same situation, guys. This is another one where an exterior has to equal the sum of the interiors. So 120 equals 47 plus X. 73? 73. 73. Awesome. All right, so close. We're almost done. Last problem, something I want you to see here. Please note, there's a couple of different ways to do this. You can either move these measurements over here, you can move this over here, but this is using no choice. All right, this is using no choice. I know basically at the end of the day that if I have two angles that are congruent to of one triangle congruent to two angles of another triangle, well then these two have to be congruent as well. All right, so really it doesn't matter how you do it. I think I'm gonna solve for this. I'm gonna say that 58 plus 66 plus no, I shouldn't say X. Let's call this C equals 180. Some quick math here. What is that? 124? 124 plus C equals 180. So C equals 56. All right. Here's the whole idea, guys. No choice. If this angle is 56 degrees, then so is this one. And we know this is 2s plus 10. So I'm just going to work right off of this. And I'm going to say 2s plus 10. I'm going to move my 10 over. And I'm going to say s is 23. All right, so again, I know this went a little longer than I wanted it to. I hope that you guys understand some of these concepts. We will be trying some more practice problems on your own in class. Have a great day.